Welcome. This is Area Classification Training, presented by Vincent Woods Wedlick, myself. This is an Industrial Business and Technology Training Institute Incorporated course, ibtti.com. This course is not for resale. If you have any questions, you can contact me at vwedlich@gmail.com. Industrial Business and Technology Training Institute Incorporated is an educational institute that focuses on training engineers and technicians. This series of training courses is for educational purposes only. I'm not trying to promote any of the products that I talk about in this educational training teaching series. Before you purchase or install any equipment in a hazardous area, ensure you consult the manufacturer of the equipment that you have purchased and install the equipment per the manufacturer's safety and installation guidelines, and make sure you read the safety manuals. This course does not cover the entire subject of area classification. We skip around and leave critical portions out to limit the length of the course. For an exhaustive study on area classification, please consult a local professional engineer who specializes in this area of study. And it's really important that you pick a local professional engineer, local to your area. Safety. Be safe. Get local help. Contact TUV, UL, MET, ETL, or your local government-approved third-party certifying agency to sign off on your installation. This presentation will not make you an expert. Hire a local professional engineer who is an expert in this field to ensure you are following your local rules and laws. This course, again, is for educational purposes only and does not assume any responsibility for misuse of the information presented in this course. It is imperative that you seek local help from a licensed professional engineer and or an OSHA-approved NRTL prior to installing any equipment in a hazardous area. An OSHA-approved NRTL would be somebody like TUV, UL, MET, or ETL. Any and all equipment that you do install in a hazardous area must be stamped and registered with an OSHA-approved third-party nationally recognized testing laboratory such as MET, ETL, UL, TUV. No self-made or manufactured equipment can be installed in a hazardous areas unless these devices have been thoroughly investigated by an OSHA-approved NRTL. Credits and references used to prepare this teaching educational series: OSHA, UL Standards, National Fire Protection Association, USA Department of Energy, Public Domain Files, vendors literature such as EGS Appleton, vendors literature, Krauss-Heinz, NFPA Article 70, which is the National Electrical Code, vendor literature, Hawk and CMP Glands, vendors literature, ATX EGS Group, IEEE, IES, Wikipedia, and my personal insights to the subject. I have been installing equipment in hazardous areas for 16 plus years. Okay, here we have a picture of the world, and you can see the United States is in red right here. When you install equipment in the United States, you need to follow the National Electrical Code. It's compulsory. When you are installing equipment in Canada, or the Canadian areas here, you need to follow the CEC. Note, look at Alaska is actually following the CEC and not the NEC. It's kind of interesting. When you look over in the European areas, you have the CENELEC compulsory which is your CE or ATEX standards. And then the rest of the world, Mexico, South America, Africa, parts of the rest of Europe, and Australia, they follow a number of different standards, IEC, CENELEC, NEC, or others. And a lot of times all you have to do is just find out what standard you need to follow. Once you've determined which standard you need to follow, and they've agreed to it, you just follow that standard. It gets real expensive if you're following a standard that is such as CE, ATEX. Those standards can get real expensive, unless, of course, your manufacturing company is from those areas. A little bit more about the CENELEC member states. I think they probably expanded some of these, but obviously Australia, Belgium, Denmark, Finland, France, Germany, Greece, Iceland, Ireland, Italy, Luxembourg, Netherlands, Norway, Portugal, Spain, Sweden, Switzerland, and the UK. And you can see they have the EX, the Epsilon X. That tells you that it's an explosive proof or an explosive environment, or the equipment is rated for an explosive environment. And we'll talk more about that later. You'll also notice later that they have EEX. EEX is for the CENELEC approved or ATEX approved. And then the EX is the IEC approved. Conformity of ATX products. ATX is a company that is owned by EGS Group. With European standards, the CENELEC, EEX, so you have the two capital E's and the small x. With international standards such as IEC, you have the EX, the one E and then the X. So if the equipment is being installed in a CENELEC member or European state, then you must have the EEX on the equipment itself. And you have to search for all these certificate of conformity documents. Basically, when you put together a CE file or an ATEX file for a Class 1, for let's say a Zone 2 area, you can self-certify a CE or a Zone 2 area. In order to do that, you need to put together a large technical construction file. It's a lot of work, and it's a very expensive process. If you're a manufacturer, it's usually not a problem because you're manufacturing the same things over and over and over. So once you've put together one file, you can pretty much use that for the remainder of your product lines. If the area is a Zone 1 or Zone 0 classified area, you cannot self-certify this area. You must use a authorized notified body to install that equipment, such as TUV, BASIFA, places like that, or companies like that. I'm going to go ahead and talk about a little bit about enclosures. These are Nema type enclosures because we do talk about different enclosures, and I'll compare these Nema or American enclosures to IEC enclosures. Obviously the first one I'm not showing here, but it's a Nema 1 or type 1 enclosure, and that's just a general purpose indoor enclosure. A type 3 enclosure is an enclosure that is intended for outdoor use, primarily to provide a degree of protection against windblown dust, rain, sleet, and external ice formation. And there's different types of type 3 enclosures. You have type 3R and type 3S. The type 3R enclosure really protects you against a falling rain and external ice formation. And when you walk up to an external transformer and it has a rather large opening with looks like about a 45-degree angle piece of metal where it allows air to flow into it and through the bottom and out the top, but it doesn't allow rain to come into the side of it. So they have open ventilation, but it's at an angle so the rain doesn't get into it. The 3S enclosure is similar to type 3 and 3R, except the actual it's actually rated for sleet, or it provides a operation of external mechanisms when there's ice laden. Type 4 enclosures are intended for indoor or outdoor use, primarily to provide a degree of protection against wind-blown dust and rain, splashing water, hose-directed water, and external ice formation. So here you have a type 4 enclosure, and you could take a garden hose and spray that enclosure at different angles, from the bottom up, from top down, and it won't get the equipment inside that enclosure wet. Whereas a 3R type enclosure, or any of the 3 enclosures, if you took a garden hose and sprayed it from the bottom up to the top of the enclosure, you'd get the equipment inside the enclosure wet. So type 4 enclosures actually provide against that splashing water or hose-directed water and external ice formation. The 4X enclosure is identical to the type 4 enclosure, except the X is the corrosion resistant. What this means is it's made out of something like stainless steel or some types of plastics. This is a very common enclosure on an offshore job. Very expensive. These are Nema 4X stainless steel 316 or 304 enclosures. The type 7 enclosure, which we'll be seeing here shortly, is a specific enclosure which is really for indoor use only. A lot of people don't know that, and you see these type 7 explosion-proof enclosures outside in refineries and what have you, but really they were intended for indoor use only. And the only ones that are allowed to be outdoors is like Appleton has a type 7/4X. What that means is the enclosure is rated for the explosion, which we'll talk about later, and it's waterproof. It actually has a gasket around the inside of the enclosure so that it prevents water, and then it has a protective epoxy coating for a corrosion resistance. So you can actually specify these explosion-proof enclosures for 4X. And you can see here it says indoors in locations classified as Class 1 groups A, B, C, or D as defined by the National Electrical Code. We'll talk about that later, what a Class 1 group A, B, C, D environment is, and you'll understand that. Type 9 enclosures, we don't really see those a lot in the Houston, Texas area, or any gas area. Where you see these are in Class 2 areas. Type 9 enclosures are used for indoor, again, locations classified as Class 2. We'll talk about what a Class 2 group E, F, G area is in a moment. Type 12 enclosures are really intended for indoor use as well, and they are protect against dust, falling dirt, and dripping non-corrosive liquids. You see type 12 enclosures in control rooms a lot where there's a dust problem and things like that. You'd think with a higher number, type 12, that it would be a higher rating, but it's not the case. It's just dust proof. Okay, so up to this point we've talked primarily about the American classification for enclosures. Nema 1, Nema 3, Nema 3R, Nema 3S, Nema 4, Nema 4X, Nema 7, 9, and 12. In IEC terminology, they actually have an IP number, and it's 2 IP numbers, so IP 56, for example. So the first number is the protection against solid bodies. So here a IP5 would be protected against dust or no harmful deposits. Or an IP6 would be completely protected against dust. An IP3 would be protected against solid bodies larger than 2.5 millimeters, tools and wires and things of that nature. And you can see in this example they've got a little device that they are trying to poke into the enclosure. The second figure is, so here you have, if you had an enclosure 5-4, so the first one would be protected against dust, no harmful deposits, and the second digit 5-4 would be protected against projections of water from all directions. You can see that right here. So here The IEC terminology is actually kind of nice because it gives you the ability to really define what type of protection you want. A real common one would be a 56. A 56 would be protected against dust, no harmful deposits, and then the 6 will be completely protected against jets of water of similar force to heavy seas. And then here is a basic comparison between the Nema type enclosures and the IEC enclosures. A type 3 is equivalent to an IP54, a type 4 or 4X is equivalent to an IP56, and a type 5 is equivalent to an IP52. Really, if you look in the back of a Hoffman book, they actually show you a type 4X is a 65. So it varies on who you're talking to as to what you're doing. But as you can clearly see here, it says that you cannot be used to convert IEC classification designations to Nema type numbers and vice versa. So, you know, some local inspectors will allow it, but you need to be aware that when you do buy a manufacturer's box and you're trying to follow a specification, that you make sure that the box is rated exactly what the specification calls for. And here's an example we were talking about. The example is an IP56. So the first digit is dust protected, and the second digit is heavy seas, powerful water jets. In the USA, we follow the NEC, and the NEC is Article 500. Article 500 defines hazardous area installations. The NEC is broken up Article 500, 501, 502, 503, 504, 5, and 10. So here we're going to cover hazardous locations, Article 500, 501 Class 1 locations, 502 Class 2 locations, and 503 Class 3 locations. We'll also touch on intrinsically safe systems, which is covered in Article 504. And then something relatively new, it first came in 1996, was Article 505 Class 1 Zone 0, 1, 2, and 2 locations. And 510 specifies hazardous locations. 511 is commercial garages. 513 aircraft hangars. 514 gasoline service stations. 515 bulk storage plants, and then 516 paint spray applications. This is an area, the paint spray applications is an area that really needs to be looked at, especially as a manufacturer. You specify equipment to be painted, and when they paint that equipment, they use explosive paints. And if you go into some of these mom and pop shops, you'll find out that those mom and pop shops are not using lamps that are rated for the hazardous area. A Class 1 area is for gases and vapors. So when you have like natural gas or the vapor from a gasoline pump dispenser, that is a Class 1 location. A Class 2 location is dust, such as a grain dust or sugar dust or things like that. Class 3 are fibers and flying, such as from sawmills and things of that nature. NEC Article 500.5b, an area where flammable gases or vapors are or may be present in the air in sufficient quantities to produce explosive or ignitable mixtures. This would be a Class 1 location. Class 1 locations are gases, Class 1 industries and applications. You'll find Class 1 locations in natural or liquefied gas storage facilities, chemical plants, petroleum refineries, bulk handling and storage facilities for gasoline, dip tanks, storage tanks for flammable liquids or gases, spraying areas for paints or plastics, aircraft fuel servicing areas or hangars, well drilling, oil and gas, offshore or on, pipeline pumping areas, and printing machine areas. So if you're trying to determine what type of equipment you want to install in an area, and you know that it's a chemical plant, chances are real high that you're going to be dealing with Class 1 location gases. Class 2 locations are dust, and this is covered in NEC Article 500.5C. An area where presence of combustible dust presents a fire or explosive hazard. Areas where you might see this is coal mines. Coal mines would present a dust environment, or even sugar refineries. We had an Imperial sugar factory here in Texas that had in little fenced-in, they're like chain-link fenced areas. They had these motor starters, and these motor starters were not installed in the proper type enclosure, which we'll cover later. And one of the vendors that kept going in and out of there was saying, "Hey guys, you guys are you're not doing this correctly. You could create a fire." And sure enough, they did actually create a fire. So that's kind of a sad thing that happens, and you need to make sure that when you install your equipment, or if you see something that's not right, you need to tell the supervisors of that plant, because a lot of people just aren't aware. And once they are aware, they'll step up and do the right thing. Class 2 locations, again, it's grain storage, handling, or processing plants, coal storage, handling, or processing facilities, metal grinding or metal powder producing facilities, gunpowder and explosive firework plants, sugar, cocoa, spice and starch production or handling facilities. Class 3 locations, fibers, and NEC Article 500.5D, an area made hazardous because of the presence of easily ignitable fibers or flyings, but in which such fibers or flyings are not likely to be in suspension in the air in quantities sufficient to produce ignitable mixtures. And the most common are cotton, textile, or flax producing handling facilities, wood cutting, pulverizing, or shaping plants, and then, believe it or not, clothing manufacturing facilities. The threads that come off of the clothing as they're cutting and what have you creates a hazardous environment as well. So first we covered the class, next we cover the location. So you have Class 1 Division 2 or Class 1 Division 1 areas. And so what we're trying to do is we're trying to describe an area. In a Div 1 area, you have the gas or the hazard is present all the time. In a Div 2 area, it's abnormal that the gas would be there, but it could be there. So here in Div 1 locations, we have NEC Articles 500.5B1, 500.5C1, and 500.5D1. And again, a Div 1 location is an area where the hazard exists under normal operating conditions. This also includes locations where the hazard is caused by frequent maintenance or repair work or frequent equipment failure. A Div 2 location is covered in NEC Articles 500.5B2, 500.5C2, and 500.5D2, an area where ignitable gases, vapors, dust, or fibers are handled, processed, or used, but which exist only under abnormal conditions, such as containers or closed systems from which they can only escape through accidental rupture or breakdown. Note, no electrically conductive dust are included in Class 2 Div 2 atmospheres. Set areas that would be Class 2 would be like a blowdown valve. It would be abnormal for it to open, but if it did open, then it would allow the gas to seep out. I would say a flange, on a pipe if the flange connection, they do leak over time. It's kind of debatable, but usually you would classify that area and put a bubble around it, a 3-foot diameter bubble or 3-meter diameter bubble, and say that that is a Class 2 or Class 1 Div 2 location, depending on the liquid or the gas that was inside that pipeline. Comparison of Div 1 and Div 2 areas for gases. Here they have a gasoline pump, and the area inside the pump itself is a Div 1 location, and the area around the pump is a Div 2 location. So they've got 18 inches away from the pump, and then 18 inches, it actually extends up from the ground 18 inches, and then with a 10-foot diameter or a 20-foot diameter radius around that area. So when you walk up and put gasoline in your car, you're actually exposing yourself to a hazard, right? Which is a fume, the vapors of the gasoline. Air is obviously lighter than some of the gases, and here you have a heavier gas. It reminds me of that physics lecture where the guy says an impervious lead balloon, and he's got a very heavy gas, whereas he has a very light gas. Helium would be really light, right, and it would just rise real quick, or hydrogen would rise real quick, whereas methane is a heavier gas, and it might drop, and it would actually gather around the bottom of the tank or the gasoline area. And if there's actually a area where, let's say right here, if this went down like a little sump area, that little area down there would be a Div 1 location. So if there's a ditch or a little submersion, then that would be a Div 1 location. Lighter than air, vapor density less than 1.0 gases. In the National Electrical Code, Article 500, you'll find a list of all the gases, and they give you the vapor density. These gases tend to dissipate rapidly in the atmosphere. They will not affect as great an area as heavier than air gases or vapors, except in enclosed spaces. Such gases seldom accumulate to form an ignitable mixture near grade level, where most electrical installations are located. A lighter than air gas that has been cooled sufficiently may behave as a heavier than air gas until it absorbs heat from the surrounding atmosphere. Heavier than air, vapor density greater than 1.0 gases. These gases tend to fall to grade level when released. The gas may remain for a significant period of time unless dispersed by natural or forced ventilation. A heavier than air gas that has been heated sufficiently to decrease its density may behave as a lighter than air gas until cooled by the surrounding atmospheres. Applicable to all densities, as the gas diffuses into the surrounding air, the density of the mixture approaches that of air. A while back, you hear about these every once in a while, where they take petroleum, or not a petroleum, but a methane gas, and they pump it into salt wells. When these salt wells or salt domes release that gas can fill up a whole valley and it'll just be a heavier than air gas, and then when it ignites, the whole area blows up. And you hear about these in the news and what have you. And obviously the point here is, if you are dealing with a gas that is greater than 1.0 vapor density, then you need to know, hey, if I have below grade areas such as ditches, those ditches are now classified as Div 1. And then the areas that are above that, 3 feet above that, would be Div 2 areas. Okay, so now we've talked about class, like Class 1, Class 2, or Class 3. And then we talked about division, div 1 and div 2. So if I had a class 1 div 2 location, then I know that that's a class 1 is a gas. The div 2 is it's abnormal for that gas to be released in the environment. If I had a class